Thank you so much for joining this lesson. We're going to discuss physics paper 1, a question from a linear motion and also uniform circular motion. Number 14, part A. A car moves from rest with a uniform acceleration of 1.0 meter per second squared for the first 20 seconds. It continues at constant velocity for the next 30 seconds, and finally takes 10 seconds to decelerate to rest. Part 1. Determine the velocity reached after 20 seconds. So look at this. Initially, this car is starting from rest. That means our small letter u equals to 0 meters per second. Then we have an acceleration, which is constant. This is 1 meter per second squared. Then now this is happening for 20. The acceleration is happening for 20 seconds. What about the final velocity attained? So now we tell ourselves that acceleration is usually given by final minus initial out of the time taken. So the acceleration of 1 equals to the unknown final minus the initial of 0 divided by the time, whereby it is 20 in this case. Therefore, 1 equals to v out of 20. So that when you cross multiply by this 20 to remain with v, the value becomes 20 meter per second. So this is now the final velocity attained. The final velocity attained is after the first 20 seconds. Part 2. Sketch a velocity time graph for the whole journey. So in this whole journey, we're supposed to know that in a velocity time graph, there is a first an acceleration here, whereby the object is moving uniformly with a certain acceleration for the first 20 seconds. Then now, we are told that for 30 seconds, the car is going to sustain the uniform velocity attained. The uniform velocity attained. Yeah, like that. Then after that, it's going to take 10 seconds to get to rest. That means it's going to decelerate uniformly. So it shall decelerate now uniformly to 0 within 10 seconds. Decelerate to 0 within 10 seconds. So this is to mean we have a maximum of 20 meter per second, but on the time side, whereby time is in seconds, this is okay, from 0, the first 20, next 30, the value of t at this point will be 50. When we talk about from 20, the next 30, sustaining the velocity of 20. Then in the next 10, this car is going to decelerate to 0. So in the next 10, from the 50th second now, we shall be at 60. So that is how the sketch is supposed to appear. Look at part 3, whereby we are told that from the graph, determine the total distance covered. It's good for you to remember that total distance covered or displacement, total distance is usually given by area of the graph or area under the graph. In a velocity time graph, area under the graph will give us the total distance covered. So let's get the area this area can be done in alternative ways. We can take the whole area as one shape, which is a trapezium, or we calculate in portions whereby we talk about the first triangle, a rectangle, and the third triangle. Then we add the three shapes. So let me prefer the first option, in which case I'll say that this is a trapezium, whereby the parallel sides, this side and this one, the parallel sides are having lengths equivalent to, the first one is 60 from the bottom, then the upper one is going to be from 20 to 50. This one is having a 30, then the lower one 60. So we'll be talking about half plus half into A and B multiplied by 8. Half the first parallel line, the second parallel line, and the height between them, which is 20 for this case. So I'll be talking about half by 90 by 20, and this will give us 900 meters as the total distance covered. Yeah, 900 meters. So that is how we get the total distance, just finding the area under the graph. Please understand that interpretation of the velocity time graph. On the sloping sides of this graph, you should know that if we get gradient at this point, it gives acceleration. It gives acceleration. If we calculate gradient on the other side, whereby the gradient is negative, it will give us deceleration. To give us deceleration. So let people be informed. This one will be deceleration. That will look at part C now of this wonderful question. And remember that you people can acquire airtime of any amount from our facility here. You just need to go to the M-Pesa, Lipa na M-Pesa. Then the pay bill number is displayed on the wall, 73 73 56. Then now you go to the account number, whereby you enter your own phone number, Safaricom, Airtel, Telcom. After entering this particular account number now, you proceed to enter the amount that you'd like to spend. Then now you complete your transaction, and the airtime shall be disbursed instantly to your M-Pesa, or to your line, sorry. So you get airtime instantly from your M-Pesa for any line from our facility here. Feel free to share with your friends. Yeah, so thank you for that. Figure 9 shows the path taken by a matatu traveling on a horizontal ground. That is a winding road. The speed of the matatu is constant. The speed of the matatu is constant. That means the mass also is constant, because along the way, it doesn't stop to load more or to offload more. Therefore, speed and the mass for this particular matatu are constant. We can see the figure here. You can see point A on the path. The journey continues to B, C, D, E, F, G, but identify with reason the point along the path which a load placed loosely on the rack or the carrier of the matatu is most likely to roll off. And according to me, I would say it is at point F. Let me give you the explanation, because we are told with reason, explain this. It's good for you to know that as the vehicle moves along this particular road, which is a winding road, such that it has to negotiate a few corners, because on a hill you can't just go straight upwards, you have to negotiate a few corners. Now, you're supposed to know that this is a circular path to some extent because it is negotiating corners. This is a circular point at B, at C, at D, at E, at F, at G, all that. But now look at the sharpness of the corner at F. You know, we say when negotiating the corner, you need centripetal force. Now, the centripetal force is usually provided by friction between the ground and the tire. And how do we get frictional force? Or do we get centripetal force, which should be provided by friction? Mass, V squared, out of R. Now, R, which is the radius of the circular path at every particular corner, because the R at A is different from B, C, D, E, F, G. So we have a smaller R for F, and that means if the R is too small, according to this, the smaller the R, the smaller the radius of the path, the greater the centripetal force required. This means at F, it might require a greater centripetal force than the wheels can provide. At F, it might require a greater centripetal force than the wheel versus the ground can provide, because it is the wheel ground friction that gives us a frictional force, which provides the required centripetal. So centripetal force to sustain the vehicle in a circular path comes from the friction between the wheels or the tires and the ground. So that is what happens. Now look at the next question in this part. We will talk about part C. Consider a body moving in a straight line with uniform acceleration A. Its velocity increases from V to U in time t. Show that the displacement S is given by S equals to UT plus half AT squared. This is a derivation question. And a student should go systematically, whereby initially we say that actually this is called the second equation of linear motion. Second equation. So we can begin by talking about the first one, which comes from the definition of acceleration, V minus U divided by T. And when you multiply by T, you will get AT equals to V minus U. This means we can choose to remain with V as the subject, and this will be U plus AT. U plus AT is called the first equation of linear motion. Now, by definition, when a certain object is accelerating, remember it's not moving at a uniform velocity. Therefore, when we talk about displacement covered S, it's going to be average velocity, not velocity times time. If velocity was uniform, we would have talked about velocity times time. But now, velocity is varying. So we talk about average velocity, U plus V out of T, over 2. Average velocity, then multiplied by the time taken, But now we can say from equation 1 of linear motion, V is usually provided by U plus AT. U plus AT. So now, in our expression for S, U plus, instead of V, now we substitute V with U plus AT, everything over 2 multiplied by time t. At this point now, we can group a few things together. Like this becomes 2u plus AT out of 2 multiplied by t. Yeah. We can talk about S equals to, when we have 2u over 2, that can simplify to u. That one can simplify to u. This can simplify to u. Then we add AT divided by 2. That becomes half AT. But remember, there is a t outside these brackets. So now we can further conclude that the value of S shall be given by, when you open brackets using t now, to be ut plus half AT squared. Looking at this, you discover that we have now derived the second equation of linear motion. When you get back to our videos in shifting grades, I encourage students to just explore our videos, and you shall be discovering that we've explained the extraction of the derivation of the 3 main equations of linear motion. Even the third one has been derived there. But for now, we've seen the first linear motion equation and also the second linear motion equation. Part F, figure 10 shows the pattern formed on a tape in an experiment to determine acceleration of a trolley. The frequency of the ticker tape is 100 Hz. The tape is pulled in the direction shown. Pulled in this particular direction, determine part 1, the initial velocity. So if it's pulled to that particular direction, it means that initial velocity is between P and Q, because the tape will be marked by the ticker timer for dots between P and Q before we reach the side which is having AB. Therefore, initial velocity, remember, velocity is generally given by distance over time. So the distance here is 32. The distance is 32. So we can make it as a unit. Instead of 32, we start working by 0.32, then divided by the time. Now, the time, we call it periodic time, the time from one dot to the other. In paper 2 physics, we talk about periodic time, which is usually given by the reciprocal of frequency. Therefore, the reciprocal of frequency shall be 0.01 seconds. So we have to take the inverse of the frequency provided for us to get periodic time, or the time taken to make one dot. So from one dot to the next, we are taking an interval of 0.01. So 0.01. Now this is the division that is going to give us the initial velocity. And this one is 32 meters per second. The final velocity. Therefore, as the tape continues, we can see the last dots made are between A and B, which means the final velocity is going to be 0.12 instead of 12, divided by 0.01, again, because the time taken is just the same. This will be 12 meters per second. Something interesting that you're supposed to notice is that this trolley is generally decelerating. And so we should expect a negative acceleration, because what you are finding is acceleration. We should expect it negative because it is a general deceleration. Just from the look of things, we can see the final velocity is becoming smaller than the initial velocity. And even as you can see from the tape, within 0.01 seconds, it moved for a distance of 32 centimeters. But now within the same time interval, as it finishes, it's able to cover only 12 on the final side now. So if it's able to cover 12 within 0.01 seconds, then this is an indication that the particle is decelerating. So now we proceed now to covering, to getting our acceleration. Acceleration generally provided by V minus U out of T. It means that our acceleration shall be V minus U out of time. And how do we get time? Let's go here now. For us to get time, we need to take the periodic time multiplied by, count now the intervals here, and this is how we count them. I want people to be very alert now in this case. Between the two spaces, between B and P, we count the complete spaces here. So there is 1, 2, 3, 4, 5, 6, 7. That is 7 plus. Now, between the regions themselves, we take the number of spaces. And I'm talking about spaces, not dots. Please take my words keenly. I am discussing spaces and not dots. I've not touched any dots. So within the spaces now, within AB and within PQ, how many divisions are there? How many spaces are there? We have one space, one space. Now we take their average, or rather we take the total spaces within the regions divided by 2. So we have 1 and 1 over 2. So we take half a space from AB, half a space from PQ. That becomes a total of 1. So I'm getting now 8. So it will be 0.01 times 8. This will be negative 20 divided by 0.08. This is going to be, when we take negative 20 and we divide by 0.08, this is giving me negative 250 meters per second squared. That is a being acceleration. SI unit should be meter per second squared. Remember consultation line 0704153366. Please reach out for any consultations. Otherwise, thank you so much for being around.